Hello, everybody. This is Naveen Balawat. I'm a senior principal with the financial services consulting practice, focusing mainly on compliance and analytics. I'm going to be facilitating few sessions on data analysis using R. So there are a lot of people who have evinced an interest in learning a little bit more about R and almost the whole process of like doing data analysis and what are some of the best practices and what have you. So I decided to do this session. The session is organized into okay. This I have organized this whole series into 5 sessions. The first session is going to be focused mainly on basics of R. And we're going to like take a real life data set and kind of like, I mean, whatever we learn as part of the basics, we're going to try and test that out and apply some of those principles as part of the first session. Second session is going to be slightly more advanced in the sense we're going to download some stock prices, do some analysis around that, do some visualization, and eventually kind of like, I mean, simulate some future stock prices using Monte Carlo simulation or what have you. Session 3, I believe this is by far the most important session because we typically tend to struggle with data. Data is not readily available. We might have an understanding of the relationships of the data, but we don't really have data available. This is an effort to almost bridge that gap, almost bring the knowledge that we would have gathered in engagements and basically kind of like, I mean, have the ability to create data sets which are adhering to some of the relationships that we would have understood, so that we are able to use for maybe like, I mean, different purposes, right? We can create like visualizations in Tableau, or we can do analysis, we can use that to train people, or multiple different uses. I don't have to expound on that. Session 4, I thought this was I was deliberating as to whether I should do this or not. Then I decided to do this. This is slightly more in the realm of like, I mean, probability and distributions. We must have heard about popular probability distributions like normal distribution or what have you. I just wanted to show why R is so powerful. This is one of the reasons why R is extremely accessible and extremely well loved in the community, is because you have the ability to basically almost simulate like any of these, like, I mean, so-called popular distributions, right? Previously you would have like studied some of these distributions only in the form of a table that was relegated, like, I mean, towards the back pages of a mathematics book or a statistics book or any of your engineering books. So this is an effort to almost kind of bring that alive and like show as to how you could potentially generate these distributions by writing like one line commands and understanding the distributions of that. And this is almost like a prerequisite for anything that you do in statistics, right? Anything that you do in machine learning, right? You must have heard about regression and the t-statistic and all that stuff, right? What is the t-distribution? What, like, I mean, what is the difference between a t-distribution and a normal distribution? So I'm just going to just give you a little bit introduction into that, and maybe give you like a lot of pointers in terms of how you can maybe kind of get like deeper into it, and so on and so forth. Session 5, go the idea is to kind of go into a little bit of machine learning. Start with some of the supervised machine learning algorithms like linear regression. This would involve simple linear regression, multiple regression, as well as like logistic regression, which where the dependent variable, the so-called dependent variable, is like a binary variable, is a 0 or 1, true or false kind of a variable. And we'll try and like, I mean, learn few things more in the machine learning domain. Very basic, and I'm pretty sure everybody can actually use it. Machine learning is this one of those things where, yeah, there are like a lot of complexities involved, but like, I mean, conceptually there are like, I mean, basically about 10 or 15 algorithms that are like, I mean, really popular, and one can easily kind of like, I mean, master those algorithms and use it for different purposes. I'm just going to give you some starter introduction of that, so that you could like, I mean, use it in your engagements or what have you. So that's the organization of the course. So without further ado, I'm just going to dive straight into the session one. Session one, we're going to talk about the basics. As I said, what are some? How do you actually set up the environment, right? How do you actually kind of download some of the popular packages that are out there in R? What are some of the core aspects of R, and how easy it is for you to kind of manipulate data using those core aspects. So the main nuts and bolts of, like, let's say, reading files, right? How do you kind of view data that you would have loaded from a file? How do you do some basic exploratory analysis? So the first part of the session, I'm just going to focus on giving you the mechanics of, how to kind of visualize some of these things, and how to go about executing and understanding some of these different concepts. Second part of the session, we'll make it real. We'll actually load a sample data set that I found on the web, and there are a lot of those data sources, and eventually I might have a slide or two that I will share on that. We'll actually load a data set and try to understand what types of variables are there, do some basic analysis around that, and then potentially actually kind of take it forward. Okay, so let's get started with the basics. First things first, on the software, right? RStudio is by far the best software that you can use. So I would strongly urge you to download this. That along with that, obviously you'll download the latest version of R, without which RStudio will not work. Once you install this, you'll see something like this. This is the RStudio. It has four broad sections. One is where you actually kind of edit your files, write your commands, right, test your commands out and what have you. And the bottom one is the console, which will tell you as to what's when you execute commands, what are some of the output that R is actually generating. And then the bottom right corner is a helpful section which will give you information about files, the plots that you would generate, right, what packages that you have actually uploaded, right, and then some help command, and basically kind of few things that you can view, right, as part of the environment. So sometimes there are way too many warnings that R actually kind of generates. I tend to switch that off and just run that. The next command is about almost wiping the environment clean, right? So RM is removes everything, and LS is nothing but it lists the existing set of variables within the environment, and it removes that. It's a good idea to kind of clean that up. And typically you would want to kind of work in a given directory or a project, so it's always a good idea to check where you are, right? In this case, just to redo the command, so currently you are in this particular path, right? If you want to change it, you can actually reset the working directory, and really kind of carry forward from there, right? One of the main things that R would require is basically R is organized into multiple packages. I think it runs into even thousands, if not more. People tend to kind of address specific problem statements, right, and package that into these packages, right, and submit it for the community review, which can be used eventually by the broader community, if you will. So you have to install the packages. I have listed a few, right, and you'll learn to use these over a period of time. Don't really have to rack your brain on what these are for, right? Essentially they're organized into improving your productivity, making you bringing you more advanced visualization, right, handling dates and time series, right? Those are the kind of things that you typically tend to use, right? And these packages are kind of helping you do that. So first things first, you need to install those packages. I'm just going to show you installation of just one package here. So you just do that, right? And once you do that, it actually kind of appears in the list of packages that are out here. So yeah, so that is one. And then once you have installed all those packages, you would follow the same procedure there. You would actually kind of want to tell R that you would like to use those packages going forward. So you would actually kind of like do that command, and if you see, it is actually kind of like including whatever comes with that package, right, as part of this current session that you have. It's a basic thing, and you learn to understand some of these packages as you go along. You don't really have to worry about it. Like now I'm not going to go into the details of that, but I just wanted to set the environment right. So that's one. So the basic building blocks of R, just going to clear the screen here, is basically it's so powerful because one of the concepts that it works with is a vector concept, right? And we all have learned vectors, right? Vectors is nothing but this, right? And if I were to and you basically kind of define vectors like that. It could be any kind of vector. It could be a vector of integers, vector of like floating values or decimal values, vectors of characters, right? Anything, vectors of like strings, anything that you would like. I just created that vect nums, and if I just want to kind of investigate that, it'll tell you that, hey, okay, so this is a vector and it is carrying like 6 elements there, and I just like happen to specify those 6 elements here. The beauty of like this vector is you can actually kind of do operations, and like when you do operations, it affects like every element within the vector. For example, I basically multiplied every element by 2 and added a 5, right? And the resultant is this, right? Fairly straightforward. I want to raise every element and square that, right? I'm just kind of doing that. And then I would like to know, typically like these vectors have a certain length. How big is this vector, right? Fairly straightforward. Like 6. There are 6 elements in the vector, and it's telling you like what that number is. Typically, like you would want to kind of append vectors, right? Like let's say you want to append like the 2 vectors that we just saw, right? One is the vect numbers and like the square of that, and create like one unified vector. So you would like to kind of like do that. And now if you want to really look at like as to what that vector, the length of the vector says like 12, right? So let's investigate this vector. So as you see, we just appended 6 more values to a vector, right? And it's essentially 6 plus 6 is 12 there, right? On similar lines, you can actually create a vector of strings, right, or characters, right? You can actually use this. So you see, it's like 4 character vector has been created, right? So vector is by far like a building block, you can say, like in R, and it is like very powerful, right? If we just saw that you just multiply or add anything, and it automatically kind of like basically applied that for all the elements in the vector, right? So one of the things, moving on to the next area, one of the things that you typically tend to do is generate sequences, right? In this case, I want to kind of generate like a useful sequence saying from -1 to 1 and increment by like, let's say 0.1, right? And you can do this in any number of different ways, whatever suits you, right? If you see this, it's generated like in all that sequence, right? Without you really have to struggle and create like, let's say, loops and macros and stuff, right? So it generated like the sequence, right? And you can do by the, here I've chosen a decimal. You can choose like anything that you would like, right? Here. This is very useful, and very useful for simulations, very useful for like generating any sequence, generating like any set of like numbers that you would want, and so on and so forth. I'll show that to you in a bit. So here I'm generating a sequence of 1 to 100. The default increment is 1, right? So let's do this. And if I see what is there in that, it's like 1 to 100 is actually kind of displayed there, right? Similar to that, I want to append the 1 to 100 with another sequence, right, from 300 to 400 where the increment is 2, right? We'll see that like stuff, and then eventually I'm just integrating that. So that's about sequences. This is extremely powerful. I can't emphasize as to how important this is. So it's very very useful. The other useful thing that you typically tend to do is repeat like certain things. Let me clear the console here. Um, so repeating a sequence a few times is always something that you would like to kind of do, right? For example, here I would like to repeat the sequence 1 to 10, right? 1, 2, 3, 4 to 10, 4 times, right? And the repeat is extremely useful for doing that, right? It helps you kind of generate data. And here you see sequences. Again, going back into the sequences, you can generate sequences by years, by month, and stuff like that, right? Just to kind of run that. So from 1910 onwards, right, it is generating like a yearly date, right, giving you the sequence there. Here it is actually generating basically the beginning of the month dates, right, for like 12 months starting from 2000. So similarly, you can do quarters and stuff like that. So it's extremely powerful for you to generate data, right? So that's the point that I'm trying to make here. Using this repeat sequence, right? You could potentially do like a lot of things, right? The other thing that we tend to do, just going back to our Excel analogy, sometimes we want to concatenate things and stuff, right? So let's say I have like a character or a string array or a string vector, and then I would like to kind of almost collapse that. Like let us see what the string is, right? It's basically uh, four distinct values within that. I would like to almost concatenate all that stuff, right? So if I do that, it concatenates and basically kind of collapses that with a delimiter here, right? You tend to use this over and over again. That's the reason why I'm highlighting all this stuff, right? And the other thing you tend to do is basically read files, right? You have boatload of Excel files. You would like to kind of read that into R so that you could do further analysis on, right? I'll just show you this list of stock prices that I had downloaded from Yahoo very quickly. Um, Very simple. It has a date, it has the Yahoo's closing price, Microsoft, and GE, three different stocks, and that's what the file is for. It's a CSV file. Um, Switching back to this, I'm going to basically do read that file. There's a command called as read.csv. So the command is very intuitive, right? You are like reading that, and you're reading that into a variable called a stock price, right? So you have assigned that into a stock price, right? If you were to just investigate as to what the stock prices variable has, I'm going to write like this command called as head. It'll tell you, hey, okay, so it has loaded correctly. Do you have investigated that? Yeah, it has loaded correctly and stuff. And it has some defaults in the sense it assume that the delimiter is a comma, right? And the first row is a header and stuff like that, right? The basic stuff is all defaulted. You could always tinker around and play around with that by specifying different delimiters. It could be semicolon, tab, and what have you, right? So everything is all so everything is almost using the matrix in parlance here, right? Dim stands for dimension, tells you how many rows and columns are there, right? So in this case, I loaded a data set which carried the first dimension is nothing but the row dimension, the second one is the column dimension. I loaded 4,800 odd days worth of data and it carries about 4 columns, right? And if you want to kind of really get the number of rows and number of columns independently, you can do that as well, right? Which I just did. So easy enough so far. Essentially we loaded a file and we kind of understood what are the dimensions of that. And R has this powerful summary command, right, which is extremely useful, and I encourage you to use that whenever use that for any analysis that you do, right? It's almost gives you a quick snapshot into the data set, right? So if I execute this, so it almost like even tells me, okay, so Yahoo is a numeric variable, right? And it is like, what is its minimum, what is its maximum, right? What is the first quartile, what is the median. It automatically segments that into like, I mean, basically 4 quartiles, and basically kind of gives you the corresponding value, right? It is essentially telling you that, hey, the median prices for Yahoo is 19, right? And so on and so forth, and it will give you a good idea into what the data set is, right? Typically you tend to do this to understand, are there any nulls in the data set, right? Are there any weird like outliers in the data set, right? For example, I'm seeing like, I mean, value here where are like, I mean, so for Yahoo it seems to be ranging from 12 to 33, but like there's this 118 that might actually kind of seem like an outlier to me, right? You would want to kind of investigate a little bit more on that, right? And so on and so forth, right? We saw the dimensions earlier. So the other useful command that you would like to use is almost like for any variable, this is applicable. You tend to understand the structure of basically the variable itself, right? So in this case, let me do this again. So in this case, this is called as a data frame, just highlighting it here, right? Data frame is nothing but it actually you can imagine that as like a spreadsheet, right? So it has like rows and columns, right? So it is telling you that like there are 4,800 rows in the data frame with 4 variables. And what are those variables, right? Date, it says it is actually a factor variable. It did not consider that as a date, but it actually kind of considered that as a factor variable. Factor is nothing but like, I mean, basically a categorical variable, right? Hey, how many countries are there? Like, I mean, India, US, Canada, right? Like those are categorical variables. There is like, I mean, nothing numerical about that, right? So it has almost considered this data as like a date as a categorical variable, which would help you kind of slice the data, if you will. But like that's not what we want, and we'll massage that, like, I mean, going forward. Yahoo, it has correctly kind of categorized that as a numerical variable, right? Almost like a number, right? Microsoft and GE are like numbers, right? It will help you kind of understand what are the different, like, I mean, data types associated with that. Now, if I want to specifically drill deeper into, so this is the data frame. Stock prices is the data frame, and date is a field. And the way for you to access a given column, right, within a data frame, you just basically do a dollar and the column name, right? For example, here I could just do a control space and it will tell me what are the different columns in that particular data frame. I can choose that, and I can understand as to what is the structure of that, right? In this case, it's nothing but a repetition of this, but essentially you are able to understand what, like, I mean, what kind of a data type is that, right? Just for your own information. So as I said, I would rather kind of like, I mean, want this to be a date than actually have that as a categorical variable, which is nothing but like a string variable. I want that to be converted as a date. So here I'm just kind of like using some date conversion functions, which is taking this date and kind of converting it into whatever format that I would like, right? And then the key thing for you to understand here is I have created a separate column, right? In this case, it is called as revised date, right? And I'm appending that to the sheet. Now, if you go to the Excel parlance, right, you're almost like adding an additional column, if you will, right? So it's so easy for you to append a column, right? I just added this, right? And if you want to kind of like, I mean, see that, you can understand that, hey, look, now I have like, I mean, the proper date format converted here, and the data type of that is called as date, right? So now if I really look at like basically the structure of like the stock prices, it should list this revised date as well, and it actually appended that particular column here. So what you saw is essentially it is so easy for you to almost like append a date, right? You could like have a yes or no kind of a variable saying, hey, so mark this as a yes if it is like less than 2010, right? Otherwise mark it as a no, right? We could do that, right? We could do a bunch of things. Mark if it is like basically kind of like less than the average of like the overall price. Anything, whatever. You can create like in multiple columns, and we'll see that like when we actually do some real-time analysis. Here again, appending few more columns, right? I just wanted like a slice by year and stuff, year and month. I'm like saying year. Year is a function, very straightforward. Don't really have to understand much here. So we created two additional columns for year and month, right? So we have our data set. So now let's proceed and see how best you can actually want to see like basically in the data set itself, right? So one thing is one of the more useful commands is, as I showed you earlier, stock prices. So if you do a head stock price, it will give you just like the top 5 rows, right, of that data set. Typically, you tend to do this to investigate large data sets, which carries like a lot of data. Like to just understand that a little bit better. Uh, there is other ways. There is a concept called as subsetting. It's almost like you are restricting the view, right? Now you're restricting the view by actually applying some conditions, right? Or telling R as to like what rows you want to actually see, right? Here in this case, the command is just telling R that, hey, I just want like basically the 10 rows, right? And the comma space gives you basically, hey, give me all the columns, right? I just don't restrict it to just like the any columns, like basically return all the columns, right? I see this like it actually gave you all the columns there, right? So let's say I want only basically only the first column. The first column I can just create like a vector which will say first column, and then I would like basically the last column, right? 4 and 5, like let's say, right? I just want these 3 columns. I'm just going to like execute that. So date, like G revised date is what I got, right? So you could subset like it this way. Sometimes this is not intuitive, so you tend to kind of give column names, right? For example, I'm just going to say I just want MSFT, FT, and I want year, like let's say, right? So it gave me MSFT and year, like those, and only the first 10 columns. So this is how you actually kind of subset data. You could also kind of like say, I don't want like the top 10 rows. I don't want like certain kind of like data and so on and so forth. And there's like a lot of things that you could do with that, right? So here is a condition, right? I'm giving you showing you saying, hey, stock prices, give me everything that is for like 2015, right? And only give me Yahoo and Microsoft. So let us see like what it actually turns out. So it gave me like pretty much like all the data there. And so obviously it's not able to fit into the console, so it actually flew by that. So here I have like almost like an AND condition here. I'm saying 2015 and the month is 4, which is April, and give me all the columns, right? You kind of executed that, so it can give you that example, and you can validate that month is 4 and the year is 2015, right? Just a quick check on that. As I was telling you earlier, so you can actually um, you can actually ignore certain things, right? For example, running this chained command in a sequence. So first is it gives you the first 10 columns, and then I'm telling it like that, hey, I don't really need the first 5 columns of that 10, right? First 5 rows of that 10, sorry, right? So that's what it is doing. So it actually generated 10 rows, but I would like to only see the first 5 of that. Like I don't really want to see the first 5. Apologies. So that's what you tend to do, and like that's what you're actually seeing there, right? You could like basically include, exclude, right, and whatever like ranges you would like to do, right? The other thing is, typically, again going back to the Excel world, you have column names, right? And you would like to kind of like, alter, tinker around with the column names, play around with it, do any massaging and what have you. R is no different. So if you want to just like understand what are the column names, right, for that data set, you can issue a command saying call names and then that variable. Very, very straightforward, right? It gives you all the different column names and stuff. And then if you want to change it, right, for example, so this is the names, right? Now these are the names, column names are fairly this one. I want to change it, right? I could change that by actually kind of like giving certain things. Here in this case, paste command, as we saw earlier, actually kind of helps you concatenate this, right? Here I'm saying repeat price 3 times, right? Which is almost like price underscore it is repeating, and then this is nothing but a string vector with Yahoo and this. It is just concatenating those two, right? So that's what paste this one is doing: price Yahoo, price MSFT, and so on and so forth. I'm saying change the variable names, right? For like those like 2 to 4, 2, 3, and 4, right? Columns 2, 3, and 4 to what I'm actually assigning new. So you did that, and then if you see names again, you will see the new names, right? So you can play around with that. Just wanted to show you that like, and there is column names that you can tend to leverage. The next thing that you typically tend to do is, hey, okay, so I have like these prices and stuff, but like I really want to maybe categorize them into 4 or 5 separate like categories or so-called bins or buckets, right? So I would like to kind of like select. Let's say I would like to only do this for Microsoft and Yahoo, right? So I'm saying stock prices, price MSFT, and price Yahoo. So I got the bin stocks, and I got like pretty much like all the data for that, all the rows. When I did a comma without specifying the row numbers, that means it picked up all the rows, right? But it only gave me these 2 columns, right? And then I'm saying there's a cut command, right? All it is doing is taking this value, right? Taking basically the Microsoft price range and dividing that uh, into almost uh, dividing that into almost like into 5 groups, right? And these 5 groups are percentile groups, right? Like that means 20%, 20% of the population is in one group, right? Between 20 and 40% is another group. Between 40 and 60% is another group. Right? Between 60 and 80% is another group, and what have you, right? So that's pretty much how this is organized. And then it's essentially organizing things into 5 percentile groups, right? So it is organizing by the percentile of like the Microsoft price, right? So it's essentially kind of like almost ordering the Microsoft price, and the data ordering the Microsoft price, right? And it is taking the top like 20%, right? Like and assigning group 1 next like as group 2, and so on and so forth, right? Bear in mind that the top 20% for Microsoft might not be the same as top 20% for Yahoo, right? Like that's what, like I said, it's actually kind of like you know what percentile is, right? Essentially, if like there are a bunch of people, just taking an example, if there are 200 kids taking an exam, right, and they score like certain things, what do you typically tend to do? Order them, right, from the lowest to highest, right? The highest is will get assigned the 100th percentile, right? And the lowest will get assigned the 0th percentile, and then you actually kind of like basically assign the percentile rank for everybody, right? If like let's say the highest is 90 and the lowest is like whatever 45, then 45 to 90 is the range, and then people would get packed in between that, right? And the median could be anywhere between 75%, right? Sorry, 75 marks. So something similar to that, essentially that's what it is doing here. So I really want to understand what kind of binning it has done, right? So here if you see, it has actually divided that into buckets, right? it has created, like it has assigned these buckets, so-called buckets, 4.47 to 18.3, 18.3 to 21. You see that like in weird, like in bracket, that's nothing but like, I mean, whether the upper bound is included or excluded, if you will, right? Nothing fancy. You guys have seen this before. Repeating the same thing, similar command for Yahoo. Just gonna clear. Similar command for Yahoo. I just like here I'm just like, I mean, saying, hey, I would like to have like 500 observations in every group, right? And divide it into as many you want, right? Different flavors of assigning basically buckets, right? So here I'm just saying m is equal to 500 is nothing but like, I mean, hey, I would like you to I would like R to kind of like try and fit like 500 observations into a given bucket. So there is no science to it. I don't typically tend to use this. I typically tend to use the percentile like in buckets, because that's more useful to me, right? And so on and so forth. So I just assign that as an additional column to the data set, and then I'm trying to understand what I'm trying to do. So now that we created these additional columns, let us look at this bin stocks, right? Bin stocks is what we actually kind of created. So it added MSFT bin and Yahoo bin to that, and it is saying that's actually a factor variable, which makes sense. It's almost like a string. It's like a categorical variable. It's like converted like a continuous variable, which is like a thing like a price or an age, or like, I mean, basically measurement or mileage or whatever. These are continuous variables into almost like discrete buckets, right? Into 5 different discrete buckets, right? There's an ordinality to that, 1 2 3 4 5, but like, I mean, these are all discrete buckets, if you will. So if you want to really just like, I mean, understand how another useful command is like, sometimes I tend to use is basically this table command. Table command, like, I mean, gives you the frequencies. It's almost like a frequency table, if you will. Sometimes it's not, doesn't provide the most cleanest of output. So typically I tend to use the plot command. This is the first time you are seeing the plot command. Plot is like a visualization feature from R. So here in this case we divided Yahoo bin into 500, like, I mean, values. It's kind of giving you that approximate kind of height here, right? For all the bins, right? You're able to visualize this in the bottom right corner here. So that's like, those are some of the typical things that you tend to do, right? And the other thing you tend to do is, I'm going to choose a different data set here, is to almost evaluate whether the data set has any values that you don't really want, or not desirable, right? Like an NA or a null, right? And handling those itself is like there's like a lot of literature in the industry for that. Don't want to go into the details of that, but typically if you find, like, let's say nulls, you would want to, like, I mean, first of all, like, I mean, understand, hey, does, like, I mean, fitting an average make sense? Does basically fitting a median make sense, right? And this is where your business knowledge also kind of comes into picture, and say, hey, while there are nulls, I would like to kind of like, I don't want to derail my analysis, right? One is you could potentially exclude them, right? Or you could actually assign some values which you believe are representative of that business, if you will, right? In this case, I'm just like loading up like a data set called as air quality. This is one of the popular data sets that are freely available in R. And one of the beauty about R is, like, you have data sets there's a data sets package itself, which has multiple data sets that you can actually leverage, right? And this is one of those data sets, if you will. So here this data set is 153 observations. It has, like, I mean, all these different values. You see here, like, I mean, it has actually kind of thrown some sample values for each one of the fields, and has an NA, right? That means it is a null. So that's like a problem for me. So essentially what you typically tend to do is you would like to, like, I mean, almost ignore those values, right? So wherever ozone, in this case, the command is wherever ozone is null, I want to kind of ignore those, like, I mean, rows, right? Completely, right? That's what, like, I mean, it is actually kind of saying. So a bang or an exclamation in front is almost like a not condition. It's a negative condition, right? So where it is null, right? I don't want identify those and basically exclude from my result is what like this command is actually kind of doing, right? So and if you see this, there are like no nulls in ozone, right? But what? But if you scroll through this data set, I'm seeing like hey, there are like a lot of this solar wind is also an NA and so in some cases and stuff like that, right? I mean, I want to kind of understand what are these data sets where like at least it has like basically a null in any of the fields, right? In any one of the fields, right? I would like to kind of understand, right? So let me kind of understand that. So it actually the number of the number of rows, it actually kind of gave me the rows that like have at least one NA here, right? So I'm saying complete cases air quality will actually kind of go through all the columns and like figure out if there is a null or not. If there is a null, it will typically exclude that. So so essentially all I'm saying is these are like these are rows that are having issues, right? That's what like this command is actually doing. So typically you tend to kind of investigate that. As I said, one of the things that folks tend to do is like assign like some kind of a general value to this, and it could be an average, it could be a median, right? Or in the case of a categorical variable, you could like basically assign it to the most frequent category, right? Or distribute the nulls based on the distribution of the other categories. Like let's say you have 5 categories and you have like let's say another like null category, right? So the null category could be distributed based on the other 5 categories, right? So there are a bunch of ways of actually doing that. I don't want to kind of get into that. I think it's too technical for a first session. The other things that you typically tend to do is, hey, I would like to kind of understand the mean. I would like to understand like the variance, the standard deviation, the median, right? I would like to understand the 20th percentile of this data, right? I would like to understand like, hey, the 90th percentile. I would like to understand the distribution of data itself, right? So there is this very powerful command called as apply, right? Which takes like basically a data frame. You could like pump in any array or a vector or whatever you want to pump in. And then it actually kind of like it operates at a column level. 2 is a column, or it operates at a row level, right? So it is essentially the command. What the command is doing here is it is taking these columns, right? Which are like the G, Microsoft, and Yahoo price, right? And it is computing the mean of that. Right? Let us kind of go ahead and run this. So if you see this across all the Yahoo prices, it is actually kind of computing a mean and Microsoft and so on and so forth. Like here, yeah, here it makes sense for us to kind of compute it like like this. But there could be use cases where like you would want to understand like basically the average or like the maximum among like all the columns. But you're operating at a row level, right? You could do that as well, right? I could easily kind of like I could easily say like let's kind of change this command a little bit. For example, I could easily say at a row level, I want to kind of understand the maximum of price between all this. So let's say maximum of price between all of them, right? So it will give me all the rows, right? It will give me all the rows, and like it basically kind of identify the maximum value for all the rows, right? So that's what it actually did, right? So it worked on at a row level. So here it worked on the column level, but here it worked on the row level, right? So I hope this is clear. This is extremely powerful. You tend to use that for like doing your row operations and column operations. So just taking this further, so I just said I computed the mean, then I computed the standard deviation, right? Computed the variances, which is nothing but like the square of the standard deviation. I computed the median, right? And sometimes you can grow tired of actually kind of doing that, so you use the quantile function, right? The quantile function is quantile function helps you kind of like evaluate the distribution, right? Given a data set, it is actually kind of like what it does is it actually orders the data set and kind of gives you whatever quantiles you are actually representing here, right? Here I'm saying generate like basically like let's like follow through this command, right? Generated the sequence is like a, hey 10%, 20, almost like this deciles, right? Like 10%, 20%, 30%, so on and so forth. I would like to understand like when basically um, what is the value that corresponds to like where like if you order the Yahoo price, right? Like from like ascending to descending, right? So what price corresponds to like a cutoff for like 10% of the population, right? So that's pretty much like what I mean by that, right? So that's what your percentile is, right? So that's what it is actually doing. So you see how powerful this is, right? It is essentially saying I would like to kind of understand like the deciles, right, for this distribution, but across all the columns, right? Which is so very powerful, and in a separate session I'll show you how you do this in Excel, and like how kind of cumbersome it is for you to kind of like maybe potentially do this, right? So I ran this and it is telling you, hey, the 10% pop, like the 10% like cutoff for like whatever price Yahoo is like 4, and so on and so forth. It's kind of giving you a distribution as well, right? So that's what like this is useful for. So just to recap, so far I'm just going to go through this. So far we have learned few things about like setting up of the environment, what kind of software package you would like to use, right? How you would go about installing packages, right? And you'll learn a little bit more about these packages as you start using basically the software more often. And then how would you kind of like, let's say, tell R that you would like to use certain set of packages which are already loaded, right, in the R environment, right? We talked a little bit about how powerful vectors are. We looked at numerical as well as character vectors. We talked about how sequences are so useful in generating vectors, right? And you can play around with like even sequences all day long, right? We talked about repetitions. Repetitions are kind of like useful. Like let's say I want to repeat like 1 to 12 for like 1 to 12 for 20 times, 1 to 12 20 times, right? It helps you kind of generate that data, right? Repetitions are useful. Paste command is almost analogous to concatenation in your Excel. Extremely powerful, extremely useful, right? You can collapse, you can kind of like do whatever you want with the paste command. And then reading files, right? Reading files and almost like seeing as to what the structure of the files would be. So here I've just read a CSV file. It could be a text file, it could be an XLS, it could be anything, right? And you have the flexibility to provide what is the delimiter, what is the almost the string, the quote string, right? Typically the strings are quoted with like a quote, right? You can specify all that stuff. I will encourage you to play around with that. And one of the ways in which you can study a given command is you can say !read.csv, and then automatically on the right hand side, if you see here, you get basically the help commands with that. And the good thing about this help is not only it gives you the literature, but also kind of gives you some examples that you could follow through, right? That's the beauty of that. Or you could directly kind of come to this window and like type whatever you want to understand. So we looked at concatenation, we looked at loading of the file, we looked at understanding the structure of like, let's say, a given data set, right? Here we saw that we understood how what subsetting is all about, and you could subset based on rows and columns and both, right? And you could have logical conditions that dictate as to how you want to subset and stuff like that. Subsetting not only kind of like helps you select certain things, but it like also helps you eliminate certain things, and which is what we saw in this command, in this like in this execution that we did. And you can actually give column names and stuff. The other thing we learned about is basically almost categorizing like a variable, right? And creating additional columns with that category. we talked a little bit about the NAs and why NAs are a nuisance. What are the ways of and means of handling that? NAs could be eliminated completely, right? You could eliminate, like, I mean, you could eliminate in the row that in the column that you're operating in, or you could eliminate in the entire data set, like, I mean, across all the columns, right? It's up to you, right? Or you would want to investigate a little bit more on why, like, these are NAs, right? And you would like to kind of understand a little bit more and apply your business kind of like knowledge on top of that and apply a default on top of it. So those are, like, I mean, few things that we can do there. So when it comes to descriptive stats, typically you tend to do your means and standard deviations, the kurtosis, right? Like, I mean, the skewness and what have you. And I'll tell you, like, I mean, I'll talk about a little bit more about like the distributions in the next half of the session. But yeah, it's you can visualize it, right? Or you can, like, I mean, basically kind of like, I mean, if you are like extremely comfortable with, like, I mean, data, you could, like, I mean, do your tables and get data in a tabular format and investigate that. We saw this, right, where we ran the apply command and we kind of like generated basically means, average, standard deviation, medians for all the columns, right, that we had in the data set, and we had chosen the price columns there. So that's what we have there, right? And then we also saw finally how do you generate basically the quantiles, right? Like here I generated like basically the deciles, right? Like which is like 10%, 20%, all the way to 100%. It's kind of giving you a distribution of, like, I mean, the data, right? And percentiles are nothing but you are organizing the data, right? From top to bottom, ascending to descending. And then almost like in putting a cutoff, right? If 10%, what is the value at 10%? What is the value of 10% of the population? What is the value at 20%, 30%, 90%, and so on and so forth? That's what you did, right? In that, it's extremely useful to understand, like, I mean, the distribution, right? So as I had said earlier, like, I mean, this is kind of egregious to me, saying, hey, 90% of the population, right? 90% of the 4,800 odd rows that we have are like less than $41, right? But like there seems to be this, like, I mean, this outlier where, like, I mean, where, like, I mean, you could investigate a little bit more. For example, I could, like, I mean, I could have said 95%, 96, 97, 98, right? And I can bet my bottom dollar that, hey, there's this like 3 or 4 outliers in the data that is actually kind of like pushing that to that, right? This is not to be construed that, hey, there is 10% of the population which is, like, I mean, at 118. No, right? This could be just 2 outliers, right? And 2 outliers among, like, I mean, 8,400, right? Which is a very, very small subset. So those are the things that you could infer from like distributions here, right? So one final thing before I basically kind of mark this session to close is the whole matrix operation. Typically you tend to do matrix addition, multiplication and stuff. I'm not going to teach you as to like what matrix multiplication and matrix addition is all about, but I'm just going to give you some examples, right, as to how to do this, right? For example, I'm constructing 2 vectors here, right, M1 and M2. So that those have 16 values. Like, let's say, let's investigate M1. M1, it has, like, I mean, these 16 values, and M2 has 16 values, right? So now I really want to kind of create a matrix, right? The way you create a matrix is, like, let's say I chose this M1, which is the 16 values, and I created a 4x4, right? And it is like saying the ways and means in which you can create like a matrix. You can say, hey, this 16 ones, you could actually wrap this around by actually going across rows, right? Or you could go across columns, right? You could do that. So that's what like this command is doing, right? So 1, 2, 3, 4, 5, 6. If you want, you could like even go columnar, like 1, 2, 3, 4 on column wise, and so on and so forth, right? So best practice, any variable that you create, like initially when you're learning R, it's a good practice to understand the structure of the variable, right? Sorry, I didn't assign that. So the structure of the variable to understand what it is. So here in this case, if you notice, just highlighting here at the bottom, it says it is actually an integer matrix with the first dimension being 4 and the second dimension is also 4, right? That's what it is actually telling you, right? So the second matrix I'm going to do by column. So if you see this, it's matrix 2, and if I show you what this matrix 2 is, like, I mean, it actually went by column 1, 0, 1, 2, 3, 4, and so on and so forth. Some basic operations of, like, I mean, matrix additions, right? Matrix addition, and you can multiply every value within a matrix by a scalar, right? In this case, it's a 2, right? You can get that. And matrix multiplication, right? Hey, okay, I want to kind of multiply this matrix by other matrix. You just kind of, like, I mean, do this, right? And you have a bunch of, like, I mean, cool things, and if you are interested we can talk a little bit more, but for an introductory session I'm going to skip over that, right? So you can, like, look at the diagonal, right? You can look at the upper triangular matrix, right? Which are the upper triangular matrix. It's giving you like a logical array there, right? So you must have heard about determinants of vectors and stuff. You can compute determinants, right? And so on and so forth, right? So just rounding off the session, I'm just going to do a quick portfolio math example, right? I have a portfolio of, like, I mean, 3 stocks, right? 20%, 50%, and 30%, right? For Yahoo, Microsoft, and GE. I'm just going to assign the weights. I have this XTS command, which is nothing but, like, which is actually a command which will which actually converts the dates into a time series format, which is conducive for doing a bunch of analysis. I'm going to do this this price, right? All it is saying is it's basically kind of taking this data frame, choosing all these 3 prices for the 3 things, and it is saying order by basically the revised date, which was the date column that we just created, right? It takes that and it basically kind of, like, I mean, internally organizes data sequenced by the date. But this is extremely useful for doing analysis, and I encourage you to kind of learn a little bit more about that. So here I'm computing the difference, right? So the difference is nothing but, like, it actually kind of compares row 1 to row 2, right? So for example, if I do a head of PR. So for example, all it is doing, all the difference command actually does is it actually kind of, like, I mean, does the difference from 1.344 to 1.375. The beauty of that is it actually does that for all the columns, right? That's the beauty of that, right? And then since the first row doesn't really have, like, let's kind of, like, I mean, go through this in detail. So if you see this, that's what it has done, right? It has 1.344 minus 1.375, and the first row is an NA because, like, I mean, there's no row beyond that, right? It has actually kind of done that. The reason why we converted this into an XTS, right, is because you don't want to be dealing with the sorting of, like, the dates and stuff, right? And you want, like, the software to do the sorting piece, right? And the best way to do that is just like, I mean, create that, like, variable so that it is able to clearly understand that the data is sorted by the date, and, like, I mean, and you don't really have to make any assumptions about, like, I mean, sorting, right? That's the reason why we do that. So here in this case we did the diff, right? But I don't really want the first column, so I'm saying, hey, like, I mean, just give me from 2 to this, and that would be my returns matrix, right, if you will. So if you just investigate the returns matrix, so it gives you all that stuff. So this is the annoying part about, like, I mean, R, like, I mean, where the results kind of go. So what do? You do a head of the returns, right? So it kind of gave you the returns, and it gave you as to what you need to look at and stuff. Hey, I want to apply the mean returns. You just saw the apply command being used earlier. So let's kind of quickly look at that. So mean returns. This is the mean returns. So I have, like, basically the covariance of the returns, right? How, like, there are 3 variables. I want to understand the covariance of, like, those returns. So, like, let's kind of, like, investigate that. This is just giving you the covariance of it. It's not correlation. So I can do a correlation, and correlation, as you guys know, basically kind of extends from -1 to 1, right? So if I were to do this, so it gives me the correlation of like basically this vector. So immediately it jumps out that like, I mean, everything is positively correlated, which is good, right? But the correlation is not all that like, I mean, high, right? I can see that Microsoft to GE, like in the correlation is pretty high, right? And you can assume that like these are all bellwethers on their way down, and which don't really make like, I mean, too much money these days, right? It's not like an Amazon or one of these things, and you can draw some inferences, right, from that. So portfolio weights is nothing but like, I mean, I don't have to teach you guys this, but essentially weights by the mean returns will give you basically the portfolio, right? It has a portfolio of like, I mean, 3 stocks. So the weights multiplied by the mean returns will give you the portfolio return. And the standard deviation is you basically kind of like, I mean, do some matrix multiplication to arrive at the standard deviation. T stands for transpose of a given matrix. So as you know, weights is a vector. By default, any vector, and this is something that like, I mean, you guys need to like basically commit to memory, is any vector in R is a column vector, right? So now, see, if you see, I did not specify that it's a column vector, but it is a column vector, right? And this weights is a column vector. So now I'm doing like a transpose of the column vector, right, to essentially help in multiplication, right? So I cannot multiply a weights by the covariance. Covariance is basically a 3 by 3 here, right? I cannot multiply a 3 by 1 against a 3 by 3. So I just need to ensure that the dimensions need to order up, right? So you have like a transpose, you have a covariance, and you have weights, right? So pretty much like I'm do that. Sorry, I think I never ran this command. And the portfolio weight is this, right? And 18% is the portfolio, like, I mean, basically portfolio standard deviation, right? Just like, I mean, quick idea in terms of like what you can do in R, right? As I showed you, so very basic stuff, like, I mean, loading the file, data frame, analyzing the data frame, looking at the values, looking at the null values, right? Converting any time series that you have like into something which you would like to kind of analyze using a time series, doing your basic like descriptive stats, right? The mean, median, mode, average, and the quantiles, if you will. And then doing some basic like matrix multiplication and matrix math. So this is the basics. So the next session we'll cover a real life scenario as to how you would go about doing a data analysis. These are just some introductory commands and stuff. Feel free to take this file, play around with the commands, get yourself acclimatized to RStudio, work on basically the commands. Look at like, I mean, look at like the output, right? Do your own commands, if you will. I'll try and introduce like an exercise section, but I think these are all fairly kind of like, I mean, self-intuitive, um, uh, to almost like, I mean, get your like, I mean, head around this and play around like, I mean, basically this information, right? So see you in the next session. Thanks.